Nigel is Technical Director at SecureAge, and from a software development background, he started his career in IT security with Entrust Technologies in the early days of PKI, and his mission at SecureAge is to help organisations take a data-centric approach to information security. So in this next talk, Nigel's going to look at the merits of a data-centric approach for security and how penetration testing must extend into scenarios where the data has already successfully been stolen. It will also look at some recent breaches and explore how they could have been mitigated with security built into the data itself. If you have any questions you want to ask, you can enter them into the Q&A box on screen at any time. Nigel will be joining us for Q&A at the end. Slides for all the presentations will be available on the CRESTCon website after the event, and videos on YouTube. Hashtag CRESTCon UK to join us on social media, and over to Nigel.
Hello, my name is Nigel Thorpe. Today, I'm going to talk about a data-centric approach to IT security, one which will no doubt add some penetration testing scenarios, but which is able to deal with the prevalence of breached data. I heard a news article recently that discussed the new trade deal between Australia and the UK. One particular comment struck me, that the UK government's export trading approach is still focused very much on things, despite the fact that around 70% of the UK's GDP is in services. It struck me that there's a direct parallel with the prevalent approach to cybersecurity, where data is held behind multiple layers of barriers. Data is frequently treated as a thing that can be stored away in a secure strongbox where it is deemed to be safe. I can see three significant problems with this approach. Firstly, this audience is acutely aware that there is no such thing as 100% information security. We must assume that some unauthorized party will gain access to network and system access. My second problem is that the IT department doesn't know what data is out there, nor where it is on the network, let alone on home workers' devices. This could be data which should be secured in a data store, or some other information such as planning documents, corporate and market analysis, personal files, and so on. According to a 2020 report from the Ponemon Institute, around 2/3 of organizations do not know where all their sensitive data is. My conversations with IT security people backs this up. I frequently hear that data could just be anywhere. Finally, data is not like a physical thing. Data, once stolen, can be published internationally in an instant, can be manipulated and republished, can be sold many times over, and can allow a competitor to replicate intellectual property, and can embarrass organizations and individuals. In short, stolen data can be used to destroy an organization. If we continue to treat data security in the same way as real-world objects, then we will continue to suffer data theft and its consequences. Let's have a look at my 3 points in a bit more detail. It must be assumed that your organization will suffer a breach of some kind. Broadly speaking, there are 3 ways in for the cybercriminal: by duping a system user into executing malware or otherwise opening a backdoor. Secondly, by having access to a user account, either stolen, purchased, or guest credentials, and not forgetting the disgruntled insider. And thirdly, by exploiting a vulnerability or infrastructure component, for example, a VPN bug or stolen password. The VPN password route is reportedly how the Colonial Pipeline incident started. This is an interesting case because it's typical for critical control systems such as the pipeline to operate in isolation, so that they can't be attacked from outside the organization. It therefore seems likely that the pipeline was shut down not because its control systems were hacked, but because the billing system was rendered unavailable, as reported by CNN. The stolen data was clearly a major concern as well, judging by the rapid ransom payment. If that data had been encrypted in a way where it remained scrambled when copied to the cybercriminal storage, then the loss of 100 gigabytes of data would not have been a concern with regard to information exposure. It would have been what I might call reverse ransomware, making the stolen data useless to the criminals. Lindy Cameron of the National Cybersecurity Centre recently pointed to the dangers and high incidence of ransomware, commenting that every organisation, large and small, has a role to play in defending organisations and the economy from cyber attack. Penetration testing performed here should have included the scenario where data was successfully stolen, If this kind of scenario had been tested, then the discovery that unprotected files could be exfiltrated would have meant that remedial measures could have been taken. Now let's move on to my second point. Data could be anywhere, and we don't even know what the data is. Most organizations I speak with implement a policy where data is tightly secured where it is held in a central system. These data security silos include databases, document management systems, and increasingly in cloud storage. Many of the security mechanisms used are very comprehensive, often employing multi-factor authentication, zero-trust networks, and access control systems. This is all great, but frequently the security policy doesn't take account of real life. In real life, people export data from applications, databases, and file stores for all sorts of reasons. It could be for research, for data analysis, and even just for getting around the system. Add to this all of those ad hoc documents which get created to help with planning, corporate finances, and reporting, and you'll find that information is spread far and wide. And until organizations revert to the modern day equivalent of the old dumb terminal, this exported data and newly created information lives outside the secure data stores. This is all made worse with our new home and hybrid working environments, where security measures are weaker and where staff are more likely to cut corners than in the office. According to a report by Apricorn last year, more than half of IT decision makers in the UK believe that remote workers will expose their organisation to the risk of data theft. Now pensions suffered a data leak in December 2020, where a contractor unintentionally posted user data to a public software forum. Not quite sure why the contractor had exported 30,000 customer records and then accidentally posted them on a forum, but my point is that the data was exported, ultimately resulting in a damaging data breach. And I can't move on without mentioning an old story, the Equifax data breach. I'm sure you know the story, and I won't dwell on it other than to mention the plain text file that contained administrator credentials. Clearly, this must have been against security policy, but real life is like that. People don't always do what they're told. A universal, data-centric approach to encryption could have defeated both of these breaches. If all files had been encrypted, no matter where they were stored or copied, then the data would have been useless to the criminals. These cases indicate the importance of a penetration testing approach that incorporates possible actions by real people doing unexpected things. If the inspection simply examines how a network and its systems can be breached, then it's missing the point that a successful attack means the cybercriminal has gained access and data is then there for the taking. And since data can be found at the endpoint in personal network stores or within ad hoc folders created by an administrator or on a server, then the discovery of this information should have been part of the pen testing process. After all, the cybercriminal will be looking for the same files. My third concern is that data is not a physical thing and should not be treated as such. Obviously, if a car is stolen, the owner doesn't have it anymore. And when the police recover it, the owner gets the car back and the criminal no longer has it. We all know data doesn't work this way. Cybercriminals, if undetected, can steal data over a long period of time. And organizations have been known not to be aware of such theft, even for years. Once data is out there, it can be traded and used in further criminal activity, such as identity theft, targeted phishing, or purchasing user credentials so that ransomware attacks can then be executed. REvil, the ransomware as a service group, benefit from this kind of activity. The REvil group supplies the attack tools, while an affiliate hacker needs to find their own way into their chosen target network. Purchasing user credentials is a quick way of achieving access so that a variety of other hacking tools can be used to map the network, gain administrator privilege, and exfiltrate data. Finally, the REvil tools are used to disable systems in the network. Ransomware victims increasingly find themselves in a position of further extortion after the first attack. When the first ransom was paid, did we really believe that the cyber criminals would destroy the data they stole? I think not. And what if stolen data is embarrassing to either the organization or an individual? In the case of the renewable energy company, Invenergy, the data included not only contracts and project details, but also reportedly very personal and spicy information about the CEO. While company resources should not normally be used for personal purposes, who's going to question the CEO? Insider data theft also remains a problem. Tesla suffered such a breach at the hands of a disgruntled employee who wrote code to export masses of data, including manufacturing processes, confidential photographs, and videos of manufacturing systems. The code was designed to exfiltrate data even after the employee left the company. While Tesla moved on and continues to grow in strength, other organizations that have suffered intellectual property theft have not fared so well. And of course, there's Edward Snowden. This was both an insider theft and caused deep embarrassment for multiple government or agencies in different countries. IT security measures must therefore extend into data. It's then important for comprehensive penetration testing to not only identify the gaps through which an attack can be made, but also to establish the breadth of data which can be accessed. Of course, remote working makes this an even more interesting challenge. And finally, data can be read within the corporate network. It should also be established whether information remains readable once copied to a cybercriminal's own storage. So what do I suggest? Encrypt everything. All data files, no question, no selection, no choice. And test that data remains encrypted when it gets stolen. But we already encrypt everything, is what I often hear. But generally, everything means all data is encrypted when it's stored where it should be, in its security silo, the database, the application, the document management store, or in the cloud. And sometimes everything means that the organization has rolled out full disk encryption to their systems. I recently became aware of one large organization that suffered a cyber attack which involved data theft. They made a major decision following this incident, whereby they mandated full disk encryption should be implemented on all corporate systems and also on systems used by all suppliers to the organization. It was felt that this was how they could ensure security throughout the supply chain. Full disk encryption is all about encrypting physical devices. Now, correct me if I'm wrong, but surely it's the data that has value, not where it happens to be stored. And as I've discussed, once unprotected data is out of the box and in the wrong hands, it's impossible to control. While document management systems and data encryption technologies use authentication and access controls, full disk encryption, after the drive is unlocked, does not. Once the system is running, full disk encryption enforces no control over who gets decrypted access to which data on the drive. And when information is copied to another drive, it gets decrypted without question. Full disk encryption is effectively no encryption on a running system. In fact, that's the beauty of it. It's completely invisible once your system's running. But the last time I checked, data theft that involves ransomware, backdoors, compromised user accounts, social engineering, and phishing all rely on running systems. Oh, and how many minutes do you expect your core servers to be down per year? Okay, so if a drive fails and you throw it out, full disk encryption will make sure that the data cannot be recovered. But how often do you throw disks away? Sometimes encrypting everything means all important information. That's fine, but how do you know where absolutely all the important information is? And who decides what's important enough to be encrypted? How much time do they spend on this task? And what are the spicy images related to Invenergy's CEO? Should they have been marked as important? We might all be forgiven for thinking that many companies consider their customers' information is not important. How often have you read things like, our clients should not be concerned about the data theft because no banking or credit card details were stolen? This is usually right after the comment that it was a complex and sophisticated attack. never blindingly simple, but I digress. I realise that these words are there to reassure people, but at the same time, we often see customers being offered identity and credit monitoring services in these situations. So clearly the stolen information has greater value to the cybercriminal. Information classification is a useful tool, but if it's used to drive security policy, then there are issues. Weighing the balance too much towards automation results in sensitive information being misclassified. And giving the user too much choice also results in wrongly categorized documents. After all, people tend to do what's easiest and not necessarily what's the most secure. And as I've said, people put documents in the most unexpected locations. But file level encryption is too difficult, they say. What's the difficulty? Main concern is that file level encryption implies lots of configuration, deciding what needs encrypting and what doesn't, and then keeping on top of this in the future. We don't have these deliberations when deploying full disk encryption. We accept that everything gets encrypted. We must take the same approach with file level encryption, and then this problem goes away. In fact, with a universal approach to file level encryption, you can't end up with new locations that are not protected because the default encrypts everything. The purpose of information security is not to protect the infrastructure, but to protect the data being stored and processed within it. It is no longer sufficient trying to secure just the known devices, networks, and storage locations. A security regime that focuses only on the infrastructure is a difficult, complex, and increasingly ineffective approach, especially as organizations embrace cloud services and home working. The purpose of a data-centric security approach is to protect data at source. With this inherent protection, data remains secure no matter which device, network, or cloud service it ends up on. The sophistication of social engineering and phishing attacks, together with the vast stolen data set available to cybercriminals, means that people within organizations are easy targets. And most people in most organizations are not and should not be IT security experts. No IT security training is going to stop some employee sometime inadvertently clicking on something bad. Thorough penetration testing evaluates all avenues of attack, including those which involve user actions, user error, and plain old human nature. By ensuring that security is an inherent part of the data rather than just a secure box where it should be stored, we can deal with these human elements in a way that persists throughout the data lifecycle. Thanks for your time.
Thanks for that, Nigel. Really interesting stuff. So we've got some questions coming up. I'm going to fire them at you. Quick one to start with. So we're talking about file level encryption and people not knowing where their data is or not understanding what type of data they've got. If you've got a large organization, you've probably got a lot of technical debt built up in the past. Where do you start with this data-centric security? You know, how do you get started on this journey?
That's really the beauty of taking that sort of universal approach. So rather than worrying about where the data is or what to identify and so on, the starting block is essentially to encrypt everything. So in that way, you can deploy file level encryption across the entire organization. And basically encrypt all data files. It's certainly an approach that I mean, if you look at the alternative similar to full disk encryption, then that effectively is the same approach. But as I mentioned earlier, the downside is that once the system's running, the encryption goes away. The file level encryption maintains itself. So yeah, it is a situation where you have to do everything, but you would obviously grow that throughout the network until you've finally covered all systems.
And what about backup media?
Backup's an interesting area. Most backup tools ensure that backup media is encrypted, which is fine. the issue is that if you have a rogue administrator who they effectively have access to the encryption keys because that's part of their job, and therefore they effectively have access to the data that's on it. If you are encrypting the data at source with the file level encryption, then the whole contents of the backup remains encrypted and encrypted against that administrator. So that's sort of belt and braces.
So you mentioned key management there, and that's another question that's sort of coming up here. When you've got file level encryption, how do you manage keys for that? How do you protect the keys for that? Does that become much more complicated over time?
There's various approaches to using keys. So you can take the approach of using kind of one universal key for the entire organization. You could perhaps use keys across different groups or keys per user. And there are pros and cons to the various different approaches. Having a central management facility, yes, you have to have something to manage those keys, but by having a system that manages them centrally, you have the ability then to recover from situations when people lose their individual keys and that sort of thing. Again, I mean, there are different approaches to that, but certainly having a key management system in place is vital for that kind of thing. Yes.
Are there sort of performance impacts on the use of file level encryption versus full disk encryption, and what do you need to consider there when you're choosing to go down this model?
Full disk encryption and modern file level encryption should be using the same kind of technology. So in modern processors, you have some specific instructions on the processor which are designed to deal with encryption services. So using those kind of facilities, you're essentially not stealing processor cycles from the main processor operations. So in terms of processing, that's one side of things. We're not pulling processor cycles away. The other issue is whether the file encryption is does it need to decrypt the entire file before you can use it, or is it streaming the data through an encryption process into memory? And obviously, if you're using that kind of technology, then the impact on as far as the user is concerned is non-existent. So it's a matter of choosing the right kind of technology.
And next question we've got, file level encryption sounds like a lot of work or resource or money that you could be investing elsewhere. So what's your argument to convince executives or the board to spend the money that they need to implement this as a solution?
It really comes back to, I suppose to some extent, it's an insurance policy. But if you are looking at some of the major data breaches and going back to looking at the information that's inside your organization, what happens if that information is leaked externally? What's the damage done? So really, it's a calculation of how much are you going to have to spend in terms of recovering from the situation where the data has been leaked, versus how much are you going to spend on file level encryption. And typically file level encryption is not a hugely expensive thing to do, certainly when you compare it with the likely damage if data gets stolen. So
with the sort of situation that you've got where in most businesses where you've got sort of some on-premise stuff that you're probably managing internally, you've got some software as a service in the cloud probably, you've got things like Office 365, you've got document controls with third parties. How does this approach work when you've got that sort of complex environment, sort of somewhere between internal network and zero trust and lots of different parties involved?
Yeah, absolutely. This to a large extent comes back to the realization that we still all have endpoints, and endpoints are where the processing is done, and often where data is stored, although not always. But as I mentioned before, until we get to the point of having effectively a dumb terminal on the desk, going back a few decades, but forwards hopefully, then you have got an endpoint. It is doing the data processing, and therefore it is the sort of the controller of the data, if you like. So if the data is local, that's fine. It's encrypted locally. If the data is coming from a file server, that's fine as well, because we're still doing the encryption locally. And as it's passed to and from the remote service, it's being processed accordingly, so that the data itself remains encrypted. So it does fit well with that sort of complex environment.
And in terms of key management, so obviously a key management system, there has to be a key management system somewhere, and that's going to be the keys to the kingdom when it comes to this sort of model. Yeah. Assuming, I mean, a lot of compromises, an adversary will get into a network and they will escalate their privileges to an administrative level. How do you defend against, you know, that threat when you've got someone with admin rights and a key management system that they've probably got admin rights over?
Yes, there's a variety of tools in that respect. Clearly, using things like multi-factor authentication makes a huge difference. So that's a fairly major point. But we, I don't know where I was going with that thread. Multi-factor authentication, definitely. Yeah, there's various other strategies you can take. But the other point, there's some practical points, like actually having the key, not only having the keys available to do the decryption, but also having the right privilege levels within the management platform. There's also having the decryption tools available to actually decrypt the software once it's been exfiltrated. So there's a lot of barriers to get in the way. Yeah, I mean, one of the key things really is the multi-factor authentication.
Lovely. And what's your sort of summary of why access control is not enough?
Access control really is all about managing access to information for legitimate users. So as an illegitimate user, you're going to try and use tools promoting privilege level, as you mentioned, so that they can then walk across the network and gain access to whatever data they can. By encrypting the data so it remains protected no matter where it gets copied, the criminal only gets scrambled data. It's kind of like those inking systems for when you're moving cash around the country. If the security band gets broken into, then the cash all gets sprayed with ink, making the money useless. So if you protect the thing that you're trying to protect and sort of build that protection in this case by encrypting the data, then it makes it impossible once it gets stolen.
Thanks, Nigel. I think that is all we have time for on this. So thank you very much for that. That was really interesting. We're back at 15:40 with Kostas Senekis, who's going to be talking about how to prepare for an exam. Thank you.